Hello, my name is Adam Boyer, and I will be presenting my team's poster titled Toward a Unified Cybersecurity Knowledge Graph, Leveraging Ontologies and Open Data Sources. The original paper, which the poster was based on, was authored by myself, Jordan Wade, Alexander Amatu, Dr. Dodu, Dr. Japani, and Mr. Jason Watson. We are all part of the Angelo State University's Department of Computer Science. The goal of our paper is to put forth a new approach for creating a unified cybersecurity knowledge graph. But first, let me explain what an ontology is. An ontology can be thought of as a common vocabulary of terms that has a meaning in a specific domain. A good example could be a foot. To a doctor, a foot is a body part. To a carpenter, it is a measurement of length. And to a computer, it is a string of characters. If we are a doctor, we would greatly benefit from an ontology for sharing our meaning of a foot without misunderstanding. Ontologies can also help you make inferences from your data. An example is an ontology of family trees. If I say that Sarah is Beth's mother, then we can infer that Sarah has a child named Beth and that Sarah is a woman. After we have defined all of our rules for our ontology, we can use it as a contract for inserting data into our knowledge graph. The knowledge graph is a simple database that stores objects and relationships instead of tables of rows and columns in a more traditional relational database. For our project, we'll be using open source cybersecurity records as our data, and the Unified Cybersecurity Ontology created by researchers at the University of Maryland as our contract for knowledge graph creation. There has been other efforts to create a unified cybersecurity knowledge graph in the computer science field, most notably the SEPSES project, but these projects have not stayed up to date or did not use an established ontology. If you look in the middle section of the poster at the left diagram, you will see how our data stores are connected. We list the following: Common Vulnerability Enumeration, CVE, with 21,500 entries. Common Weakness Enumeration, CWE, with about 600 entries. Common Attack Pattern Enumeration and Classification, with about 550 entries. Common Platform Enumeration, with about 1,200,000 entries. And Common Vulnerability Scoring System, which can be calculated for each vulnerability. AARs are also mentioned, but have not been integrated at this time. In the right section of the middle column, you will see our methodology: automated data acquisition, transformation of data to RDF, which is a standard form for representing data to be put into a knowledge graph or triple store. Dynamic creation of cipher queries, cipher being the language of the Neo4 database or Neo4 knowledge graph, which we will be creating. And lastly, Neo4j knowledge graph creation. Below is a high-level architecture of our project. In the right column, you will see a screenshot of a web-based ontology visualization and exploration tool. This tool is named WebVal, and we plan to upload a live visualization of the Unified Cybersecurity Ontology for people to explore the different entities and relationships. As our project progresses, we would like to continue to add other open data sources, such as the aforementioned after action reports or AARs. We would also like to expand the ontology to include the MITRE ATT&CK and defend ontologies. Jason Watson, who co-authored this paper, has already done research into the MITRE defend ontology and will advise us on its integration. Our final goal, however, is to create intelligent cybersecurity applications utilizing our graph. An example application is a machine learning model based on the graph that can detect real-time cyber threats from analysis of log data. Thank you for taking the time to view our work, and have a great day.